So welcome students to our next lesson. Now I want us to construct a kind of a triangle. Then you get to identify what kind of a triangle it is. Is it an isosceles? Is it an isosceles nature, or whether it is an acute nature, whether isosceles or an equilateral? So let's get to construct one. So first of all, let me try to construct. So first of all, let me draw this line, which is the first line that you have to draw. So that is the line that I've drawn with my t-square, and you can see that how my t-square is lined in. Let's construct triangle. Let's construct triangle G H J. Triangle G H J. Let's draw a line of 85 millimeters. So let me assume this is 85 millimeters, assuming that you've transferred it from your measurements. I will stand here, make a mark. Again, stand here, make another mark. And you can see that my marks are very faded. Let me call this one G. Let me call it G. Then I call this one H. This is 85 millimeters. And all the time, ensure that all the dimensions, you just label them on top of that line. Do not label anything below here. Ensure that you label them on top of the line. That is something which is very sensitive. Then from there, I will construct 90 millimeters from G. Let me take 90 millimeters from G. Assuming this is my 90 millimeters, which is greater than 85. $90 You can see where my arcs are. So that is 90 millimeters. So again, let me take 60 millimeters standing at G. This is my 60 millimeters, assuming that this is my 60 millimeters. So I put an arc. So where those two arcs, for this one I measured 90 millimeters standing at edge. I marked 90 millimeters. Then standing at G, I marked 60 millimeters. So there is a point whereby the two arcs have crossed each other. So what do I need to do? I need to join them to form a triangle. So that is my triangle. So this kind of a triangle, as you can see that it is less than 90. It is less than 90 degrees, or the angles. So how do we call it? So this is and this forming N. This is an acute kind of a triangle. So this is acute in nature. So whenever we construct a triangle and you find that it is behaving like this, let's say for example, this is my line. If this is my line, this is A, B. Assuming that I stood somewhere here I meant an arc which came somewhere there. I also stood here, meant another mark. So you can see joining C to B, then joining C to A. So you can see that this is This is an obtuse kind of a triangle. So you can see that it is obtuse in nature simply because it is greater than 90 degrees. So 90 degrees lies here. So anything that is in between 90 degrees and 180 degrees, we call that one an obtuse kind of a triangle because it is greater than 90 degrees. And any kind of a triangle which is less than 90 degrees, we call that one an acute kind of a triangle. Then again, I want us to check on the different kinds of triangles once they pass in a semicircle, how they behave and their nature. So for instance, if triangles pass in a semicircle, so what do we need to conclude? Let's say, for example, let's draw a semicircle here. You get to see how the triangles behave. So if this is my t-square, you can see how it is sliding. So I will draw my line. So that is the line. Let me dimension my line to something like, let me give it something like 70 millimeters. I start here. Then again, start here. So this is A, this is B. Let's give it 100, which is better. So that is my 100 millimeters. So you take a half of that. Half of 100 is 50. So standing here at the center with the half of 100, I will stand here, then make a semicircle. So that is my semicircle. So what happens when angles or triangles try to lie in a semicircle? Any kind of a triangle which lies in a semicircle is always a right angle triangle. So for instance, if I try to draw any kind of a triangle from here, like this, to come and touch point A, this kind of a triangle, this is a right angle triangle. If I decide to draw another one of any nature, like this, again, this is a right angle triangle. If I also try to draw another one, again this is 90 degrees, so it is also 90, 90, 90. So all the triangles that try to lie in a semicircle, they are all right angled triangles. So you should get to note that all the angles that lie in a semicircle are always right angled triangles. Again, you may find that some angles may lie in a circle. So what happens when triangles lie inside a circle? So we call that one cyclic quadrilaterals. And to get cyclic equilaterals, we normally get them from a circle. So we may take a circle of this nature. So assuming that this is my circle, assuming that that is my circle, let me divide my circle. I may decide to divide it like this. So again, all the triangles which will lie in between this circle will be 90 degrees in nature. So for instance, if I decide to draw any triangle like this, so you can see that it's summing up to, this is 90 degrees. If I also try to form another one from here up to here, like this is also 90 degrees. So those kinds of triangles which behave like that in a circle, not in a semicircle, we call them cyclic quadrilaterals, and they are always 90 degrees. Again, now we are going to the construction of triangles and circles, whereby we are going to perform the inscribing and outscribing. Now, I know that when you move across most of the past papers that you come along with, you find somebody telling you, giving you a question, then you are told to inscribe a circle or you outscribe a circle. So how do you inscribe and how do you outscribe? So outscribe in outscribing and inscribing, this is the difference. We have these two terminologies, inscribing. Then the other terminology is outscribing. How do you differentiate those two terminologies? Let's begin with inscribing. Inscribing, it is a terminology which is used to mean, for instance, if you have constructed a given triangle like this, once you have been told to inscribe, somebody tells you simply to draw a circle which is passing inside the triangle. So it should exactly touch the sides of those triangle without extending outward or without taking the nature of going past those angles that you've been given that particular triangle. So for instance, if this is something like 70 millimeters, these three lines, this is also 70 millimeters. So you should ensure that your marks do not go past these lines. A line should not behave like this. It should always be inside the triangle like this. So this is what we call inscribing. So what do we mean by the other terminology, which is outscribing? What do we mean by outscribing? Outscribing, for instance, if you have been given a triangle like this, to outscribe now, you are being told that any circle that you are going to draw in this triangle, it should touch the apex. We said this is the apex. it shouldn't touch the apex of that particular triangle. So if you stand here with your compass, you should ensure that your circle goes around this like this, touching the apex. So we call this one outscribing. So I want us to get some two examples on how you get to inscribe a circle inside a triangle and how you outscribe a circle outside a triangle. Let's get the procedure. Let's now start with a circle. A circle circumferencing a triangle. A circle circumferencing a triangle. What we mean by circumferencing? Circumferencing simply means outscribing. Circumferencing simply means outscribing. So it is another terminology which can replace outscribing. So how do we get to draw such kind of a triangle? So for instance, let's get to draw a triangle here. So this is my starting line. So if that is my starting line, let's construct a triangle ABD. Triangle ABD. ABD, in which AB is 70 millimeters. So let's take AB to be 70 millimeters. So assuming that this is my 70 millimeters straight from the ruler, this one, I will stand here, make a mark. I will also stand here, make another mark. So this is A, B, which is 70 millimeters. Then after that, BD, you have been given 65 millimeters. BD, so wherever B is, B should be somewhere, D should be somewhere at the top. You don't know where it lies. And you've been taught BD is 65 millimeters. So let me assume 65 millimeters from my ruler gives me something like this. So BD is 65. I will put a mark like that. Then AD is 45 millimeters. So I will measure 45 millimeters like this. So that is my 45 millimeters. So wherever those two intersect, I will join those points like this. So this is my D. This is 65 millimeters. This is 45 millimeters. So it's a matter of you just take your compass, you place it here with the 65, you stand here with the 45, and wherever those two intersect, this is my 45, 65, then you join, you get a triangle. Then from there, now you have been told to circumscribe or to outscribe this particular triangle. So how do you get to outscribe a circle inside this triangle? So first of all, to outscribe a circle, you need to identify two lines and bisect them like this. Let's take line A and B. Then again, you join those two. You join those 2 points. Like this. Then again, you can decide to choose this side and also bisect. So you will bisect line A, D. I will stand here, make a mark. Again, make a mark, stand here. Make another mark. Stand also here. Make another mark. So what you need to do, you need now to join these two marks. Like this. So, wherever those two marks intersect, so you can see that now I've arrived at two lines. We have this line and we have also this other line. So, what I need to do is to take up my canvas like this, stand at the center. Let me call it center O. I will stand here, then adjust my canvas well. Then from there, I will try to, although mine may not be accurate, I will try to draw a circle. So you can see now this is my circle. So to come up with this circle, I think you have seen the procedure, and you can see that my circle is touching all the apexes. So it is touching here, it is also touching here, also touching here. So we call this one circumferencing, which is also the outscribing. So I said the procedure is very clear. I may show you the procedure again for you to get clearly. Outscribing a circle. I said you take up your T-square like this. Then draw a line according to the measurements that you've been given. Let me give my line dimensions of, let me call this one A, B, this is A, this is B. So assume this is 50 millimeters. Let's assume this other line, you have been given something like 20, like this. Then from this other point up to here, something like 35. So let me say, assume that they meet at that point. What you need to do is join here Then stand here, join this other side. This is C. So again, I identify two lines that I need to bisect. Let me assume this one and this other one, just two. I will stand at A, make an arc at the top. I will stand at B, make a mark below there. Then from there, I will take up my ruler like this. Then join. Then from there, I will identify the other line. You can design to define this one, or you can design to work with AC. So let's, for instance, take AC. Let's define line AC through bisecting it. So I will make an arc at that point. Then make a mark below there. I will also stand here, make a mark, make another mark. So wherever those two marks intersect, I will take up my ruler like this. Then join. Then from there, where those two lines intersect, let me call it point O. I will take up my canvas like this. Then standing at O, I adjust my canvas to touch one end of my triangle, the apex. Then from there, I will try to draw a circle like this. So you can see that I've drawn my circle. This time round it has been accurate. So this is the circle. So now that is the procedure of circumferencing a triangle. Circumferencing meaning drawing a circle which is touching the edges of the triangle. Then we will stop there for now. Let's meet in our next lesson. In our next lesson, we are going to study about how now you get to draw a circle inside a triangle, whereby we call that one inscribing. So thank you so much. Follow the same procedure. I will attach the procedure also typed. You get to draw and see whether yours will be similar to this. So thank you so much.